Hello friends, welcome to Compiler Hacking. In this video, we're going to work on string interning. If you don't already know, string interning is something a compiler can do where instead of, say, comparing foo to foo or foo to bar, which is inefficient, if we know what our strings are going to be ahead of time, we can convert them into numbers and oops, this would be a 1. Convert them into numbers like this, and then we're just comparing numbers instead of comparing the string. We don't have to compare each individual character and iterate through them, and it's just way more efficient. And we have a thing in Natalie called a symbol, and so just like in Ruby, trying to think of if I have an example here. Board slam, does it have any symbols? Yeah, it has a couple symbols here. So these here are symbols, numbers, and answers. They're like strings, and in fact, we could do this, and that would be totally acceptable in Ruby, as it is in Natalie. But if I put a colon in front instead, then what that's doing internally is converting it into a number. And so every time it sees this symbol, it's a number of some sort, and it's much faster to compare. And the way we do that in Natalie is we have symbol value header, and this is an object, and so it's not technically a number in Natalie yet. I'm getting there. The way I did it is I implemented a hash map, and at runtime, I'm looking up the symbol in this hash map and converting it into this object on the heap, or returning the object from the heap if it already exists. So definitely not super efficient, and we'll just cook up a little benchmark here to show how let's see how slow it is. So if I do symbol.rb and I say, I don't know, 100,000 times, and we'll do a foo and a bar and a baz, and I don't know, is that enough? Yeah, that's good. I think that'll show probably what I'm trying to show. And make sure I save that. And I do bin Natalie, compile that into symbol, symbol.rb, and then we'll just do that first. And we'll run time symbol. That's a little bit too fast. So let's make it go. Let's make it go 1,000,000 times. Well, I lost my cursor. There it is. Not quite used to using the terminal inside of Vim yet, so it's not second nature yet. Okay, so it takes 2/10 of a second to run, and I think that well, let's look at the code that it's generating. So if I do symbol.rb, oops, .rb, my fingers are a little cool tonight, and I look at the C code that this is generating. Then somewhere here, here's our block, and what we're calling is symbol value intern for these 3 strings over and over and over again 1,000,000 times. So as you could guess, not super efficient. So what I want to do is take an intermediate step, and we're still going to do it at runtime, but we're going to do this once at the beginning of the program instead of 1,000,000 times. And I think by the end of everything, we should have something that's a little bit better than 2/10 of a second. And that's the goal. So let's see. Let's jump right in and see what we can come up with. So we have our little benchmark script. And where do we start? Where do we start? So I think in pass 4, we have process intern right here. And so our compiler, if I do bin Natalie d pass 3 of symbol.rb, did it again, .rb, we're going to see intern value putter here. And so what I want to do is bubble these up to the top somewhere, somehow. So we're going to do this. So I I think what we need is at the top of pass 4, we already have source methods. Let's do symbols. And we'll just make another little hash here. Source methods. It's going to look a little bit like this. So let's do symbols to C, symbols.size. This is, let's just call this name. Or var name or something. I don't know. It's not const char though, is it? No. It's going to be symbol value pointer array symbols dot keys dot map. So I don't want to do this though. I think I just want, so let's make this declare symbols maybe. So this is going to have to go somewhere, and then we're going to have to def init symbols. And we'll set that, I guess we have some repeat code here, but that's okay. And then we're going to loop over and do symbols.each, do, name, we'll say var name, symbol name and index. And let's come back to this. I'll put a mark here. And where are we going to create these? So we do this with source methods somewhere. I just don't remember exactly where. Where do we do this? Fascinating. So, we're not actually adding the source methods anywhere. What? That's suspicious. Did I break something? So what about source files? Okay, so we're doing this here. Yeah, that's a little bit suspicious. Am I no longer using, is this dead code? Because there's nothing actually adding to it. I did refactor the method stuff a little bit recently, so yeah, I think that's it's actually some dead code. Well, you know, it happens. So declare symbols, init symbols. So we need something like this. We'll do that in intern. Yeah. Okay, I'm following my own thoughts here. Process intern. So right here, we're going to need to. We're going to need to, let's see, symbols, and we're going to put the name in here, and we're going to say symbols.size, so it gets the next index. So the first one will be 0, and the next one will be 1, and so on and so forth, which is great. And then we don't want to do this intern right here. We want to, I guess we want to return var name. Where's my var name thing here? This is a little bit repetitious. Yeah, let's not make it so repetitious. Def symbols var name, because we're using this all over the place. So symbols var name, and then and this is going to be only if it doesn't already exist. Symbols name. And we're just going to return it like that. So anytime we see process intern, we're going to stick it in this hash with a new index. And then we're going to return some C code that will reference that. So we haven't really built this array yet. But we will. So yeah, let's see. Now we need to do it here too. Is this a different type of symbol? It's just wrapped in a value putter. So it's going to be very similar to this. I wonder if I can just do process intern exp and actually let's just do it right here. Process intern exp. Yeah, so now it's wrapped in this value putter with a name. Cool. Okay, so let's go back to our mark where we were. So init symbols. So this is where we're actually going to initialize them. And I think what that's going to look like. Oh, we don't need this anymore, do we? Was it symbol var name? Yeah, symbol var name. So don't need that anymore. And this is going to be the index, and this is going to be this, and there's going to be symbol, value, intern, env, and the name.inspect, so it gets a little quotes around it. And yeah, we're making good progress here. So this is where we're actually going to initialize all the symbols at runtime at the very beginning of the program, and we're going to do it once instead of a million times. And so where are we inserting source files to C? This is where we will do declare symbols. Now let's just go look and see where that's happening at. So if I do this, what do I get back? So right here, I'm declaring this array with 4 elements. So we know that part's working. And then we know this part's working because we're grabbing the first one, the second one, and the third one, which is great. And there's another one here, symbol var name 3. That must be the dot times. So over here in our example code, we're calling dot times, and so that is turned into a symbol as well. So we have 4 symbols. Fantastic. And so now we just need a way to insert all of the items into this array, and we want to do it. Where do we want to do it? So this is our whole C program here, C++, I should say. Build top env. I don't think I can do it before build top env because the stuff that we need isn't there yet, but we could do it. I guess I could do it right underneath here. So in main, let's give it a shot. So main CPP, let's jump down to here, and this is kind of some weird templating stuff that there's probably a better way to do this, but this is how I've been doing it. And I just add a little comment here and put what I want it to be. So say symbol init. And yeah, I'll just do some replacement and do our symbol init right there. So in pass 4, I think top matter. Where does top matter go? It goes in nat top, nat body. So I think I want another one of these, and I want this to be symbol init, and I want this to be symbol. Thought I already had symbol in it. Maybe it was init symbols. Init symbols. So let's look and see what that code looks like. Oh yeah, what have I done? That's not right. Oh, I need to do DECL? No, I need to do something though. Maybe I need to do map, and I need to join it by a new line. Oops. I think that's right. Let's see here. Ah, yes, that looks much better. Except that's not valid C++, so let's go fix that as well. So this needs to be a .2s. Let's run that again. So that's looking way better. So now we're doing this, and I don't know, is that enough? What's gonna happen? Ooh, did I run make? Did anything change? A lot of stuff changed. Symbols var name. Oh, well, I have that as a literal somewhere. Symbols var name. What did I do wrong? Oh, right. I need to do some replacement on that. So let's give that a try. Let's run this. And got a failure. So let's run this through GDB. I think I need to increase the font size just a little bit. I want to make sure everyone can see. Run, backtrace. Oh, okay. I think I made a mistake with our object files. So this is kind of another little quirk of our compiler. We have to compile some things before we can compile the main program. And so one of those is lib exception. No, source exception. Yes, source exception.rb is a Ruby file that we precompile into an object file, but it doesn't have a main. And the problem, of course, is that I put this in main, and we don't have a main when we're precompiling those other object files. So, compiler.rb, and I have to remember how I did this. Oh, I think it just goes right here, because this is sort of the main of those precompiled library files. So let's see if that fixes it. I have a feeling I missed something else. But yeah, I don't know. It's worth a shot. Don't need the GDB, hopefully. And it worked. Did it work? Symbol.rb. Let's just print something. Oh, that's going to be really big. Let's do it 1,000 times. And run that again. Looks like it's working. Cool. Let's put this back and see how fast it is. -c. Oh, I should have done it as a new file. Okay, time. I think it was 2/10 of a second. And now it's, ooh, look at that. It's 0.05. So it's 3/100ths of a second, 4/100ths of a second, something like that. So I mean, we're definitely almost an order of magnitude, an order of magnitude faster, essentially. That's great. That's awesome. So do our tests pass? That's the big question. Let's just do a clean test and make sure it precompiles all those object files and make sure I didn't break something, because there's a good chance I did. Well, I had a couple failures. Not too surprising. One was in the compiler test, which actually does a bootstrapped compiler. So we compile our compiler with Natalie, and then we use that to compile some code, and there's some sort of inception problem there. And then the other one was the REPL test, which actually crashed Ruby, MRI Ruby, not our Ruby. And I'm not sure what's going on there. So yeah, I guess we'll just have to figure that out. My guess is that the REPL needs some sort of exception. Yeah, so, okay, let's just try this. So if I run the REPL here and I say foo, is that going to crash? Of course it is. Because we can't add to that array REPL RB. So the way it works is it does a little compilation and uses FFI to open the shared object and run the code, passing in the environment each time. That's how our REPL works. And okay, so I need to see what it's doing. I need to, because it's been a long time since I've written it, so I need to kind of remind myself how it works. Debug. How do we pass debug options in? I've forgotten how we do that. I mean, I guess I could run right here. I could say compiler to C and puts that. Might work. So if I say foo, like so, and scroll down, here's the C that it generated. There is no, well, maybe it's down here. Yeah, here it is. Here's the symbol. So there are 3 symbols. And symbol 0, 1, and 2. Okay, I figured it out. Is because we're calling eval here. We don't call main when we're in the REPL. That makes a lot of sense. So I need to rethink this a little bit. I can't do it in main, but I could do it. Oh, I don't like this. I don't like this. This is where we call eval. Maybe I can do it at the top of eval. I don't like this. But let's do it here and just see if that works. I don't trust that you rebuilt what I wanted you to rebuild. Come on, finish. Ben, Natalie. Foo. Bar? Yes! Okay. Ben, Natalie, examples. Oh, goodness. I'm so excited I can't even figure out what I'm typing here. Fib. Does that give us a number? Yes! Yes! Okay. Board slam. That's our other example thingy. Yep, 3, 5, and 1. Oh, yes, it's awesome. Okay, the other failing test. Oh, let's do the REPL test. Ruby test, Ruby REPL test. Make sure that passes. Please. Yes. And then bin Natalie test, Natalie compiler test. This one's still going to fail, but I have a hunch on why. And usually when I see screenfuls of this crap, it's because in compiler RB, yeah, I did this mistake. So you'll notice these little interpolations of an empty string. It's weird when I'm self-compiling Natalie, it replaces these strings too early, and I haven't figured out why. But if I stick this in there, then it doesn't see that token too early. And anyway, so I think that will probably fix that. Do I need to run make again? It's possible. Well, it's definitely taking a little longer. Oh, yes. So let's do our -c again. Time symbol. Oh, it's so much faster. So if I, let's see, let's go ahead and commit this. Yep. I don't need to go through all that stuff. Lib and source. And we'll say speed up string interning by doing it once at the beginning. And let's go back one and do a make. There's C. Oops. I meant to do old, or we'll say slow. And then we'll go back to master and make. And we'll say fast. So we'll do time, symbol slow, and symbol fast. Oh, it's fantastic. Well, there you go. What we did was we took the work of turning a string into a number. It's an object pointer in Natalie, but someday down the road we're gonna actually make it into a number, I think. But yeah, we took that work, and it's essentially like we're doing it up. Ooh, how did I do that? It's like we're doing it up here. So f equals and b equals and b2 equals this. And then we're replacing that here with these variables, and we're just doing that work. That makes me wonder though, could I have done this with a compiler pass? That's essentially what I'm doing in pass 4, but could I have done it in an earlier pass in a more higher level way rather than manipulating the C code? Well, it's a thought experiment. Sometimes you do things and you realize, oh, there was a simpler way. But in any case, this is just fantastic. It's faster, and I'll probably do some more playing around with it to see if it's sped up anything else like Board Slam. But thanks for hanging out. I appreciate you and your encouragement. I hope you have a side project you're working on, something you can get your creative juices flowing. And thanks for hanging out. I'll see you next time. Bye.